Perfect, yes. Awesome.
Okay.
It's. Is it on, connected?
Yes.
He's got glasses, is he here? Let's see, where's Jeff? Oh, there he is.
Thank you.
Okay, so yeah, I think that's his screen.
Yes.
There we go. Cool. Hey Jeff, how are you? You're on mute.
I didn't get it connected.
You gotta unmute yourself.
Okay,
There
now
we
you
go.
got me?
Yes, we got you. Probably this guy, I'm guessing.
Yeah.
I'm trying to figure out how to get you up on this screen here, but we're getting there.
Stepping on
Does that have an HDMI on that
Is it-
side?
Is it automatically switching between the camera where it thinks is most exciting?
Yes.
Yes.
Oh, that's kind of cool.
Yeah, it's supposed to
Perfect.
track the loudest speaker
Okay.
in the room, so. Oh, it's lovely.
We lost our pictures in the background of our conference room because this place is almost packed up and ready to move now.
Oh,
Okay,
gotcha.
we're all set here. It's automatically
Perfect.
going. Let me go get one more.
All right,
then-
Erica's here. She's gonna
Set
be in
up.
your session. So if you need anything, you can always holler for Erica and she'll come and. Yes.
Okay.
rescue you.
Great, nice to meet you, Erica.
Hello.
Are the algebra tiles around there?
Yes, and they have whiteboards and whiteboard markers.
That's excellent. And the packet is sitting somewhere there? It doesn't have to be
Yes.
printed out yet?
Packets as well.
Okay.
So we're just gonna make it full screen. Cool. I put this little guy up. You're gonna put that here.
All right.
Yeah.
That is a funky wide angle view that I can
fix that.
see everybody out there. Is that look like there's a fan of tables where they're sitting like 4 or 5 to a table? Is that right?
Like three to a table, and there are 9 tables. Yeah, kind of in an
Oh,
auditorium.
okay. I see that. I can see it. It's small because you're dominating it.
Yeah.
All right,
sorry,
that's
if I walk over here, does it get bigger?
Probably right there.
Yeah.
Here. Okay. I'm gonna get my phone.
And
so I
now
can
it's
get-
just,
He does what he wants, so this guy here.
We can change it. We
Pause.
can, see it,
Oh, yeah, now it's looking at you.
yeah, but we can change it so that there's,
Right.
it fixes on whatever you wanna fix on.
right. I probably don't need to see myself. You know,
Correct.
so that part of the screen is probably unnecessary because I'm seeing myself already. Because I've got another box that shows me. Okay, so I'm gonna
Just you
pin that
everywhere.
one. That makes
There's
sense.
someone who has the app to control it and tell it what to do. She'll be back shortly. For now, it just
Okay.
does whatever it wants, so.
That-
Yeah.
That's fine. That'll work very well. Yeah, do we expect, I forgot how many I gave you, but are you expecting that many? Like, because you said like 9 tables of 3, that's.
No,
more.
there, I think 12 people signed up.
Yeah.
Okay.
I had 18 signed up this morning, but only about 12 showed. So,
Okay,
I
that's
would-
all good. Then
Yeah.
we've got more than enough tiles and stuff for them because they really only need a bag for every pair. But if there's not that many people, you could probably give a bag to each person.
okay, yeah. And I just started this morning letting them just kind of give like a 30-second synopsis of their particular teaching situation. Remember,
Sure.
some of them are in some really kind of non-standard kind of setups.
Right. Some of them cover
Yeah.
6th through high school, you know, so.
Yeah.
So
had one
I
this
hope,
morning,
I mean, I saw that when I wrote it up, I suggested that it was, you know, we're looking at a span from like 7th through all of high school. So if there's some people who primarily do 7th and 8th, they'll still find some useful stuff here. So that works.
Just looking at the teachers that are on here, it pretty much, I'm the only middle school one.
Okay, So we'll move
Uh,
faster through there, but that's fine. It should, it's just a following of kind of the one theme all the way up. So it gets
Yeah.
more complicated into high school.
And a lot of what we were talking about at the middle school earlier too was just, our students not having all the skills that they need and all the concepts that they need coming to us. So even though I might be teaching, it sounds like most of your districts are algebra, geometry, algebra two.
Yeah.
But even if I'm teaching algebra, if my students need that shoring up of those skills, like that 7th and 8th grade content is gonna be really helpful, so.
For sure, especially if they're struggling, then all of this hands-on concrete stuff is exactly what they need anyway, so.
Yeah.
Sure.
Yeah. So, okay, did you put anything into the, file, the Google folder that I shared with you?
Yes, everything is in there.
Okay.
They don't need to access it during the course of this, but
Right.
but all of the items that we're working with today, including I've got a larger Google Doc that follows a flow of something, and then some slides, and then all of the actual lessons. They're all in the folder there.
Okay, perfect. I'll take a picture of the sign-in sheet, which has emails, and then tonight I will add everybody to the folders that they need to be added to. So you can just let them know that by tomorrow, they'll have access to everything they need.
That sounds great.
I think that's the easiest way, unless there's
Yeah.
like a mass mailing list or something, but it's not that many
Probably
to
the
add, so.
easiest.
Okay, awesome. I'm gonna head over. I'm in the other building. Gonna do some fun fractions with Play-Doh, so. You
Okay,
guys have
sounds
fun.
great.
All right.
And we should have people in about 15 minutes?
Yeah, yes.
Okay, so how do you want this to look?
How do we what?
I can fix it. I can make it essentially so it stays one way, but then once I leave, it'll stay that way. So you can't like continue.
Well, I
So you
think.
can, like, that would remove the 360.
Yeah, you didn't want, Jeff, you didn't care to have that panoramic view on there, right? We wanna take that off?
As long as I can see the crowd, I mean, I need some version of
that's-
seeing the crowd. Like,
Okay.
is that, I'm not sure if that would see, can you go? Because, yeah, that's one end. Yeah, if we try to make sure that just everybody's in that range of view, I think the only ones I would lose would be the far ends of the two front tables.
You know what if we we'll just tell them to sit here.
Yeah.
And then.
Or just
if we
not,
get a couple more, they can sit to the back edges there.
or you can bring it, just bring in, that's, now you can do that whole 2/3 of the room. Just don't do the 1/3 that's all the way to your left. Oh, now I can see everything except for, I think, the very last person of the front table. So like that table's not so,
Push them in if you wanted, whatever you
so
want
that's
to
the
do.
only one, because that's a pretty good view of being able.
There's 11 of us,
Oh, yeah, you should just make them.
so we'll just sit in the center and if they need.
Or
then we'll
Well,
pull
the
up chairs.
center and your right is fine.
Over
Okay,
here.
Yeah,
Is this
over there
good?
is fine. So those two
Perfect.
columns are okay.
Okay,
And
that
maybe-
sounds great.
Should we even just
Yep, if you'd like.
the other way? We'll just make it.
focus on those even more.
Well, now you went to the other one. Now we
you
can do
want to go
those
the
two.
other way.
It doesn't matter. But pick
Sorry.
one of the two
That's
sides.
perfect. There we
Like that,
go.
that's perfect.
That
Um,
works. Okay.
No, I'm
It's
assuming
you.
what they're seeing is more my large screen, right? Not
Yes.
themselves.
Correct.
Yeah, you're this teeny tiny little box, but your picture is filling a large screen TV.
Good. Okay. And so then I can just do, sometimes I will switch back and forth so that like when I need to use my document camera to do things, or then.
That's perfect.
Yeah, we can see that.
You do have to turn on the ability for me to share a screen,
Yep,
because right now I'm not allowed to.
we will take care of that. There you go. Does that work?
I will check.
And then, do you know, did Maddie pin? I wonder if Maddie pinned him. I mean, if it's just like that, it's fine, right?
Pinned what?
So you
All right.
can, there's the option where you can pin it, so he's always on.
Oh, I just made.
Are you seeing my screen now?
Screen.
You're seeing my screen now, correct? And not the document camera?
Correct.
Okay, all good then?
All good. Okay, and then the owl should stay how we just said it.
Okay.
Does that sound good?
Uh-huh.
Does that work? Okay.
Yeah, I think so.
You can only do it with the app. You can only adjust it.
Yeah.
You just never know. Technology. Okay. All right, Erica, thanks so much.
You're welcome.
All right, that looks great. Ugh. All right, and their expectation is that this goes till 2:30, correct? I mean, sorry, 3:30 your time.
I was gonna say yes, but you might wanna say 3:30, you might have some people leave early.
Okay. All right, I'll
I'm kidding.
Gonna be wrapping up by 3:15 to make sure that nobody's feeling anxious.
I'm kidding, we all know how long it is.
Okay, good. Did most people have to travel to come here for this session for the couple of days? Is it 1 day or 2?
It's one day.
Did most
Uh,
people like have to travel far enough that they're spending a night, or most people just come in for the day?
I would say the majority come in for the day.
Okay,
There's a few districts that are very, very remote that, like they might travel 4 or 5 hours to get here, and so they probably came in last night.
that makes sense.
Yeah.
That would be brutal.
Yes.
To do 4 or 5 hours each way before and after a session.
It would. But the majority of the teachers, would be within driving distance of a 1 day, for a 1 day thing.
All right, I'm just gonna refill some water. I'll be right back.
Okay. Just so that we're all in the camera view for him, we need to be on these two sections of tables.
Yeah, Erica, you might want to just tuck away the chairs for that last row of tables. Then you won't have to keep telling people no.
That's what I'm doing.
Oh, okay. Well, I can't tell because you're out of range of the camera view, and
Exactly.
that is the point.
Yep. Yeah, I thought I'll just. Preempt it.
Excellent.
Jeff, do you want the supplies passed out at a specific time? Or do you want everybody to take a packet, a whiteboard and algebra tiles as they come in?
You could put them out and that would be fine. Or you could let them pick them up on their way in. So that would probably be simple. You could just have them do all of that, a whiteboard, packet of algebra tiles. I don't know how many I put in there, but it may be enough for every individual to have one.
Okay. If not, we can always
I was planning on it being
pass around.
enough to be one for a pair, but having your own is kind of nice. They're all in little packets, so I think there might only be something like 10, maybe 11, 12.
Okay. There's 10. So that's enough for most everybody.
So the
There's
last two
11.
people will just have to sit down next to someone who already has one.
Exactly.
But there's plenty in there.
Yeah.
Hello,
Hello, how are you?
I'm doing well.
Good. Just the right one, how much you made it?
Well,
I give a half credit and that's all, I'm probably not type in, this is.
no, I think they're focusing more on, like, using manipulatives, hands-on. I was kind of surprised when I saw your name on the list. I thought, oh, that surprises me.
You know, it's a good thing.
All right, we'll see you.
Change, last minute change.
Not trying to chase off participants, but he's our auto shop teacher.
Oh, yeah, that might not be the most effective session for him, I would guess.
That's what- He said I might go choose one of the CTE ones. Well, maybe.
Yeah, I didn't quite hear what you said, like, or whether you said what he was, but I was like, okay, sounds like, I was thinking maybe an English teacher or something like that, and just going,
No, but I saw his name on the sign-in sheet and I thought, well, that's interesting. I wouldn't have expected him to sign up for this one, but.
I appreciate those people because I've missed for the last few years when I've been out of the classroom, because when I'm in a classroom at a high school, there's usually an auto shop where I can have good work done on my car for a much more reasonable price, and that's very fun to just go in the morning and say, yeah, give me an oil change, and they only charge you for the cost of the oil and the filter.
Kids do that, I know, and teachers kind of like it.
Right.
Yes, yeah, I know. Sorry. There's stuff that we got. Eric is studying the tissues. Let's see. It's just good. It's not sure if it would make so much. All right, yeah. Not a manager. Hello. Oh, there was. Hi. Yes. Thank you. Oh, that's one.
What scholarship thing are you doing?
It's a PEO. It's a little fundraiser brunch thing.
Are you doing it in Vail?
No,
Oh.
it's in Payette.
Oh, gotcha.
Gotcha. Yeah, it has nothing to do with school. Gotcha, I'm just bad timing. I'm putting your initials on it.
Okay, how many people do we have tomorrow?
I think tomorrow could be one.
Okay.
Yeah, I think you have 26 and compared to 35.
I need to bring another desk in then.
He was, okay, he was hysterical. Okay. Yes.
I did last time, yeah, I did last time too.
Yeah.
How many did I have last time? I think I had 26 last time.
Yeah, probably.
Did you have 20? No? How many desks do you have in your classroom?
24.
So I need 2 desks in there?
Yeah. One is right outside the door though.
Oh, that's right, the one that has all the writing on it.
Well, they switched it out because it was scratching the floor, but yeah.
Okay.
No, look at this. I've never seen a brand new whiteboard before.
Okay. Well, did you get them in rows, or do I need to get there early tomorrow?
No, we did put it in.
Okay, so I don't need to get there until like 7:30.
Yeah. It's just all you have to do is get a piece of paper and tax record on the wall.
Okay.
The labels are already on post-it notes.
Oh.
Like,
All right.
you just have to fill the post-it notes on.
And I just did it like how they were in order last time. And then I'll just grab it one done.
Yeah, but and it's all in a, like, that's just. There's boxes and like, and then her thoughts that are like, what happened to Meredith?
Who's Meredith?
Shannon, she's our librarian.
Oh, okay.
She wasn't there.
She wasn't there last time.
No.
Jody wasn't there last time.
These are the. No.
Shannon, who was there?
Jamie is.
Okay.
Erica, you think we might have a couple more people?
Oh, yeah, there's quite a
There's
few.
definitely some people missing.
There's 1, 2, there's 3 more that are on the list. Whether they have decided to do something else or just are taking a few extra minutes for lunch, I don't know.
Okay, well, we'll go ahead and get started. I'll welcome everyone. Nice to see you, even if I can't be there with you. My name's Jeff. I'm Jeff Ruby. I've been a teacher down here in California since 1991. Some of my time in the middle grades, some in the high school, and then a big chunk of time out on loan with the Irvine Math Project out of UCI working with professional development with teachers across all of those grade levels. So I'm looking forward to this session here with you. Here's just kind of the big picture of our plan. So I'm not sure exactly how it got listed, but it's okay if it got listed a little bit differently, because I think the name sounds similar enough that I've got a good session planned for you for the next 3 hours is all I'll say. And so last year, were some of you here in the session I did last year? I'm sorry, the faces are small from last year. So last year we talked more about the progression of functions across grade levels and some things we can do to gather data. But really what we move from is we do both functions, and then those functions often become one variable equations, and we have to do things to them, usually solve them. So I thought moving from functions to equations, and so as a plan to follow the development of the paired concepts of equation and solution, along with the matching skills for solving that progresses from 6th grade through the 3 courses of high school. One of the major themes or things that we give a lot of attention to in the math project out of UCI is that we need to pay attention to both ideas, developing conceptual understanding, as well as procedural understanding. And at first glance, we can often think that we've established what an equation and a solution is, and it's really just a matter of adding more and more skills along the way. But I'd actually argue that the idea of what is an equation, what constitutes an equation, what is the range of its possibilities, and what do we mean by solution, changes as dramatically as the actual skills that we use to solve. And that we should pay attention to the idea that we are in some ways shifting what students thought they understood was something. And that happened also with functions. In the middle grades, they pretty much think functions are linear, and can often walk away with the misconception that if you are not linear, you're not a function. But we keep breaking their idea of that as we move through high school to say, no, a function could also be like this, or it could be like this. And here's a new family of functions, and it's got new qualities. Well, the same thing is true about equations. And what do we mean by a solution, and what is possible with a solution moves quite a bit throughout that age span also. So we'll look at some lessons and some ways that we can help develop both concepts and the skills as the idea of equation and the idea of solution progresses. But before we get going on that, I would like to just ask, since there's really not that many of you, so that I can be aware of what maybe your needs are and what you're thinking, can you just go around and just say your name and say, like, what's the range of grades and topics that you are currently teaching? So maybe we start closest to the door and work our way around towards the refrigerator.
Jessica Rodriguez, and I teach from geometry through pre-calculus and
Okay.
trig.
Excellent.
Erica Josie, and I teach 7th grade.
Okay, sounds great. Thanks.
Katrina Gehring, I teach from geometry and statistics, and next trimester I'll be doing pre-calc and calc.
Okay, good to meet you.
I'm Phoebe McGrath, and I teach algebra 1.
All right, nice to meet you.
Brad Dalton, I teach geometry and data science, along with the pre-calculus and mathematical modeling and reasoning course.
All right, great.
My name is Gerald Winteray, and I teach geometry.
Wow, a lot of geometry teachers here.
I'm Kelly, and I teach from algebra 1 up through pre-calculus and some computer science.
Oh, you've got quite a range there. Small school?
Yeah.
Okay. You got them all. All right. So so we'll move fairly quickly through some levels of things based on what I'm seeing of you guys. But I want to we'll come back to this particular document. Oops, I just clicked the wrong button. Sorry. I'm not as proficient a Zoom user as I used to be. Don't do it as nearly as often. Sorry, can't get out of this. Wow. That's better. So before I share this general screen, well, I'll do it this way. Here we go. So I've got a document that's in a folder. You can look at it later, but we'll look at it a little bit over a course of many times throughout these next couple of hours. And just looking what happens to the idea of equation, the idea of solution, and the methods we have for solving it, they really develop very dramatically across 6th, 7th, 8th, Algebra 1, Geometry, and Algebra 2. So you weren't meant to read all of those because we're going to come back to them at multiple different times. But that's basically the flow that we're going to look at. And what I'd like to do is start at the most basic level. Do you know what grade level is very explicitly the very first, here is an equation, you should understand what it means to solve it. This is what you should be using variables, and you should even have some particular methods for being able to solve an equation. And here's the forms of an equation that you should learn, that you should know how to solve. So check with the person next to you. Do you know what grade level really kicks that off? When would students first be faced with that?
All
right, so what do you guys think? You high school people, are you really the first people to help people solve an equation?
It feels like it.
Well, then some of this will be good to go back and think about it, but by that answer, you're not the first. What grade level do you think is really explicit about starting that off?
Sixth
Sixth grade.
Okay, so 6th grade is correct. And there's just a few types of equations that they're supposed to be able to solve. And in order to do that, we might start right at that grade level with some basic tools. But what is a key thing that hasn't happened yet? So what type of numbers should we probably restrict ourselves to in 6th grade?
Positive numbers.
Yeah, we'll have to stick to positive numbers because they haven't dealt with negative numbers yet. So we don't want to throw those in. So for the moment, you've got a little bag of algebra tiles. Can you just take out some of the blues? And reasonably, if you put that in front of you, can we all agree? What do you think that represents?
3.
Okay, and that's the way we would normally deal with that. So these squares, how many of you regularly use algebra tiles? Because I think they're useful all the way up through a good chunk of high school. How many of you regularly use those? Anybody? Is that just one hand that I saw? All right, just checking. All right, so now that was the regular use question. How about, have you ever used these?
Yeah.
Okay, so we've got one more that's an ever, but not on a regular basis. Okay, so let's just take a look at how we might use those. We'd have to define something also. So this guy, we probably shouldn't call it a 1 because it looks like you're getting a lot more or like something different than a 1. Although it is matching in width there to your 1, if you notice, but this dimension is clearly not a single 1. Can you tell about how big is it?
3.5.
Yeah, and so this is kind of the dilemma, and we have to own it with when we talk to students to say that it's not perfectly 3 is true. It's not perfectly 4, but it's not truly unknown. It's somewhere in between 3 and 4, but we're going to pretend like it could represent any length we want, but it's not, it won't work out perfectly with just one number. So they built them so that they're not nice, and everybody says, that's not a unknown, that's just 3, or that's 4. So they made it halfway, part of the way in between. But we're going to call this, we're going to say it's an unknown length by 1. And so, so instead, we're going to say it's X. All right, so here we've got a piece that's X. With 6th grade, we might have to do something like then say, all right, show this to the person next to you and ask them how much that is. All right, did we all agree? How much is it?
It actually. All
right. Okay, so when students are not yet very familiar with grades, I mean with variables, they may say other strange things. Some might say 3. Some might even say just out loud 2x, which is weird, but they see the 2, they say the x, they don't say anything. Sometimes they'll say 2 and x without a plus. Those are all reasonable ideas, but we can clarify getting into this. Would you have enough information now to figure out what x is?
No.
Okay, because what are we looking at?
An expression.
Excellent. So we'd have to talk about, this is an expression, we can't solve it. If you take your whiteboard right now and in the middle of the whiteboard, just write a little, oh, you can't see that. Can you see that at all, what it says on it?
We can't see any writing.
Okay, I'm gonna make a, now can you see that?
Yeah.
Yes.
Does that now come up? Okay, so you can see that that's an equal. So if I say that I've got this on this side and on the other side, they are equivalent. And so if you could build this for a moment. All right, just in case you're getting nervous, we will move fairly quickly through 6th and 7th grade, so we're not going to stay forever here. But we want to start with this idea of this is now an equation. What can you do to this? I'm sorry, somebody say louder?
Yeah, subtract 2 of the 1s, take 2 of them away from the side.
Okay, so what would we call that you're doing when you do that? Okay, but what's our broader goal? Is there some target of what we're trying to do?
X is long.
Isolate.
Isolate, okay. I was just thinking we could call it the action of solving. We could just solve it, but those are all very, very specific, good academic words. We could isolate the variable, we could subtract something from both sides, but we could solve this. And what we have found then is some important idea. And so if you take away 2 from both sides, at this grade level, we probably wouldn't add a -2 to both sides. We'll just take away 2 from side. We'd say we've solved it. We found this and it's the solution. And so the idea of what is a solution is going to be something that grows and changes over multiple years. But in 6th grade, some of the things are pretty key. Every equation we give them will always have a solution. There will always be a solution. It will always be a rational number, and we will always set things up so that the rational number is always positive. And so there's some very limited things that are going to happen. So there's really just 2 types. That's one of them, x plus 2 equals 7. Build one other one here, and we'll move from 6th grade. Build Okay, so build that equation also. Now on this equation, can you take something away from both sides?
No.
Okay, so physically, don't say it out loud, but physically solve the equation by doing something. All right, take a peek at somebody else's algebra tiles. Did they solve it the same way you solved it? All right, can somebody describe for me what they did, and I will do it with my hand. What did you do to physically solve it?
I matched an X tile with the same number of, one tiles.
And how did you know what number it was going to be?
Well, I didn't know what number it was gonna be.
So then how could you match it with the same number?
I just moved it until they were equal.
I see. So you started giving everybody something
Yep,
and then breaking it up kind of like this?
yep. Until I got the same number.
All right. So that's great. We didn't have to know how much it was. We just had to start spreading it out equally. An interesting thing here is we don't really see in front of us the solution. We actually see the solution written 3 times, or at least represented 3 times. And we have to accept that we read the solution by only reading one of them. But that's where we get to with 6th grade. There's not a lot of complex things. If I will do 6th and 7th, and then we'll come back to that table just to organize what we know. So if that's a 6th grade equation, let's move. Within a couple of minutes, we'll pass by 7th and 8th, although 8th gets significantly more complicated. Can you go ahead and build this equation? All right, so this is one version of a 7th grade. Turn to some partner around you and tell them what you're going to do to figure it out.
And then we're gonna.
Well, I'm going to try and hold the this time.
Yeah, I really.
All right. Did anybody hear their partner say something interesting? Any, or were you all pretty much thinking the same thing?
Yeah. Yeah.
Did you go at the 4 first?
Yes.
Okay, so it comes to me pretty natural. Was our solution still a nice number?
Yeah, let's do.
Okay, so this is one of the 2 forms of a 7th grade equation. Let's take a look at a second one, which is substantially more complicated. So let's take a look at this. Actually, I'll describe it for you. On the right side of your equation, could you build 3 groups of x plus 1? On the right side, could you build 3 groups of x plus 1? And I'm just going to document what type of equation, what that is. So on this side, you get 3, and what should I use to represent groups?
Parentheses.
Excellent. So 3 groups of x plus 1, and on the left side, only build -3. Now, knowing what you guys all do, this is wouldn't be a hard thing for you to solve on paper, but see if you can actually physically use the tiles to work your way to a solution. And think about the steps along the way. So go ahead, build 3 groups of x plus 1. If you want to, you can do it with a partner. You can do it on your own and then compare. And on the right side, you're only building -3. I'm sorry, left side.
He wants us to solve this.
So go ahead and solve it physically by
Solve it.
doing things. What would we be allowed to do when we're solving equations? What are some of the actions we're allowed?
Adding, subtracting.
Adding and subtracting, but do it to both sides?
Yes.
Can we move things around on one side all by itself? Just move them?
Yes.
Yeah, that's a fair thing. We're not adding or subtracting if you just move something around. So you can move things around, you can add or subtract on both sides, and in the end, we can split things into groups.
I want to take these away, I don't have any.
That's not how it goes. I just have to do it on both sides.
Well, I don't think I add zeros because I didn't actually add any value.
Oh, that's right, we only have to do it on one side.
Yeah.
Gotta do the zeros.
And then I can take the 3 positives away. And then split it.
That's right.
How's it going in the back there? I still see a little algebra tile movement. Is it, are we close to, we got it done?
I got something for you to do the same.
Mhm.
Oh, wait, no, we didn't have that.
I know, I was
So
like, I
don't
have you
to
to do it on this side, no, we don't have to do it on that side.
All right. Let's say, 2 people in the back middle. I've forgotten your names. Can you remind me?
Gerald?
Daryl,
Yeah, Gerald and Kelly.
Gerald, and who?
Kelly.
Kelly?
Yeah. Yeah.
Okay. Could one of you tell me something I could do to start with?
But you can subtract 3 from the right side?
Okay. So if I just pick up, you mean pick up 3 and take them away?
Yeah,
But if I have to do that, I have to do it to the other side too.
correct. So then you would add those tiles to that side.
So I would do what?
Well, you're putting red, you're changing them out for red tile on the left side.
Okay. So one thing we might want to do is try and do something that is explicitly the same. Like if I'm actually going to physically take those away, I would want to have something to take away. Would it be, do you have a reasonable thing that I could just add to both sides? What kind of tiles could I put onto both sides that would have the effect you're talking about?
You can put red around.
Okay, so I could drop in 3 tiles, red tiles on this side, and then also, is that a fair move?
Yeah.
Yes.
Okay, and so why did you want to do that? What good came of that?
We have 0 pairs now.
So all of these are really equal to 0? So I can, and in a sense, I can let them disappear because they're just zeros. All right, so I'm sticking to my own limits of I'm only going to add something or subtracting to both sides, or what would be my next step? A little.
Yeah.
Splitting
Splitting
apart
apart.
tiles into groups of 3.
And what would be the name of that operation?
Dividing.
So now we're go ahead and dividing. And so, and we could now look across any one of the rows and say what our solution is. What is the solution here?
-2.
And I heard it both ways. So -2 equals X or X equals -2. Both of those are acceptable. So this is kind of rounded out. These are the limits of what types of equations we're looking at for 8th grade. I mean, for 7th grade. So let's just kind of describe that in a very clear statement here. Can you see that? Is it large enough to be able to read it?
Yeah.
Okay, so what do we mean by an equation when we're in 6th grade? They really have to be an equation of the form AX equals B or X plus A equals B. What is the solution? There's always one rational number solution, and equations are chosen to keep the solution positive. And what are we allowed to do? We can add, subtract, multiply, and divide. Basically, the use of inverse operations. Does seventh grade really change the idea of equation very much yet? Not at first with just an equation, but then they also introduced the idea of you could have an inequality. And think about what that does to the idea of the solution. So why does that mess students up, the idea of an inequality? Or why does that dramatically change the idea of what is the solution?
More than one value.
So more than one value works? And in fact, how many values work?
An infinite number.
An infinite number, and there's just a cutoff. All of the numbers above or below work, but our process of solving really remains the same. You only add or subtract, multiply or divide to both sides, although you have to be a little careful about what happens along the way. So we've got 2 years to kind of build a foundation, but then things are going to change dramatically about what do we mean by equation, and especially what do we mean by solution. Does every 6th and 7th grade equation have a solution?
Yes.
Okay. Why do these forms force it to always have a solution? Turn to the person next to you. Why isn't it possible to write an equation of these forms that doesn't have a solution?
On one side. Yeah.
It's the no solution of it.
So you might ask yourself, when you're at high school and you are with some struggling students, just to check, it's good to know kind of these developmental stages. If you see somebody struggling with whatever type of equation you're working with, you might want to look back to see where did they fall off the equation bandwagon? When were they stopping able to? Can they understand a 6th and 7th grade equation? Or was it 8th grade when something went bad? Or was it when we started introducing newer things in Algebra 1 or Algebra 2? Well, let's move on and take a look. We'll just do one 8th grade equation. Actually, let's do 2 of them. So here's a new equation. This one I'll just build for you. So build this equation. And all right, so there you go. Go ahead and build it and do what you need to be able to solve.
We're solving?
Yeah.
Yeah, go ahead and solve it physically with the tiles. See if you can work your way through. And notice it's just a minor leap from 7th grade in this particular equation. All right. Let's see. Door side middle table. Can one of you two tell me what was an option you had for starting the equations?
Well, I could identify when I had the same thing on both sides and put them sort of in a row, signifying that they were the same thing. Then you could go over them with the red tiles and say they're gone now.
So you kind of organized them, you said?
Yeah.
And then what do you mean you said you had the same thing on both sides? It doesn't feel the same to me.
Yeah, so you have one of the blue X's on each side, so I put them across from each other. And then, the two blue tiles on the bottom, I lined them up with two other tiles on the bottom. And then I split that remaining group into 3 equal pieces, and set them equal like that. Yep.
Wow. So did you actually physically remove any of them at this point?
No.
Okay, so that's an interesting idea. We don't actually have to, with the tiles, to physically remove them. Would it be fair to take away anything from both sides?
Yes.
What would you take away?
2 pairs.
Yeah, take an X away from both sides and.
So we could
two
take an X from both sides, and we could also
2 ones.
Two left.
take 2. Would it matter the order of that?
No.
No, we could take 2 and then take an X, or take an X and then take 2. But the way you've arranged this nicely at this point, can you see the solution even without the removal?
Yeah.
Okay, that's lovely. I don't know that I've ever seen anyone just say, I'll set these aside for a moment, but I'm not going to do anything with it. But it's a brilliant move. I like it. And so it's not a dramatic leap, but what happens in 8th grade, and it's a very purposeful thing, there is some coherence to the Common Core standards. It's not always there, but coherence meaning that some of the things you do in one area of your math course actually is absolutely essential for another area of the math course. You're using them and reinforcing things over the course of the year. So let's take a look at what can happen and what's disturbing. This one I'm going to just describe for you. I'd like you to be able to build it. On the left side, could you build 3 groups of x minus 2? So I'm going to say that again. On the left side, build 3 groups of an x and a negative 2. On the right side, could you build a 2x and then 6 and then another x? All right, check with the people next to you that you have the same thing and see if you can state it as an equation. And I'm just going to ask somebody to say it out loud, and I'll write it down on the equation. What was the left side?
3x minus 2.
X minus 2. And what was the right side?
2x plus 6
6
x.
plus x.
Okay, if that's what you've got, go ahead and work your way through and solve it.
I tried, but it doesn't make sense.
All right. Try to explain clearly to the person next to you what result you got or why you are disturbed.
Oh, wait.
Yeah.
You gave your equation.
Negative.
If you take all your X's off, no variable, no.
I have it.
It's not a true statement.
No.
I can remove the same thing from each side, right?
But it says equal.
Exactly. It
Yes.
says I can remove an x from each
As
side.
you say it,
And I
that's not gonna get true.
There we go. One.
All right. How about all the way in the back on the door side? Can you tell me something?
Yeah.
Then tell me something.
I get no solution on this, because when I take 3 x's away from the left side and 3 x's away from the right side, I take them off the board there, I get negative 6 tiles is equal to positive 6 tiles, which is a not true statement. There's no way to make that true.
Okay. So you have the knowledge to be able to say, this is disturbing, but not so disturbing. I've experienced it before, and I can tell you what it means,
Yeah.
which is great. But this is why this is a huge leap in 8th grade, that we are now building equations. Should you even call? Should we even call that an equation?
No.
We should.
No, there's a bit of a disagreement there, right? I mean, we're saying, should we call it an equation? Because what do we usually say about equations?
They must be true.
They are, do we say they might? And this is where we're changing on students what we're saying. We're saying it's a statement that these two expressions have equivalent value, that they are equal in value to each other. They may not look alike, but they are equivalent in value. And now we've got an equation with cannot meet that requirement, that no matter what value we pick for X, we can't have it. To me, I think it's worthwhile to recognize that this is a fundamental change in a sense, in the idea of what an equation is. What is the solution to this problem? Okay, so we now agree in a sense that the solution is to state clearly that there is no solution. Like that is the only appropriate response. So we're saying there is no solution, but at least it has a correct response, which isn't really a solution. It is because we probably, do we still hold on to the definition of solution? Does anybody know? See if you can check with the person next to you. How do they define what a solution is in 6th grade? Because that's the place where they start. And they're very clear in the standards to say students should understand that a solution is, check with the person next to you. Do you know what they would state?
Yeah.
C.
Yeah.
Okay, anybody think they got it? What do you think the standards directly say? A student should understand, and this is interesting, it's an understand standard. Many of the standards are doing standards. This one is not. It's an understand standard, and it says understand that a solution is somebody.
The value that makes the equation true.
Exactly. That's almost word for word exactly what it says. The value, I think, I'm not sure at that point they say values. They throw in some weird parenthetical, like the value from the possible values that are allowed in this situation that make the equation true. Like they're trying to get the idea that some has to be within the domain of what you're going to allow, which I think at that point is pretty excessive for a 6th grade student, but at least the rest of it without the parenthetical is that. All right, so that's a big leap in 8th grade, but there's one other leap that changes what do we mean by solution also. This one changed what we meant by equation, but also there's a big idea that's a leap about solution. Oh, before we go any further, the packet you're looking at, I'm not going to use it because I'm not going to I'm not going to use the first page of it because it was dwelling more on, that's how we could document some things coming from 8th grade level problems. But really, it's very worthwhile to start with algebra tiles where we don't do a lot of writing, but we actually just solve, and then maybe after some days and comfort, we can move on to actually solving on paper, but not be in a rush to get onto paper. What are the advantages of solving, if you're going to go back and fix something for someone, what are the advantages to solving with algebra tiles without documenting everything right from the start? Can anybody think of why it might be worthwhile to just spend some time with the tiles and not, or maybe you write it down as a teacher, but they don't? There's some very strong advantages.
Yeah, I mean, you're just gonna be easing that cognitive load on the kids, and they can focus on the concept rather than on the mechanics of writing or
Excellent. We're staying solely focused on the concept of balance and equation. Will students still make mistakes?
Yeah.
Is there any record of them?
No.
That's another beautiful thing about the tiles is when you make a mistake, there's no record of it. You just do it over again, and you don't have to erase something. You don't have to cross it out. There's no looking back and saying, oh, that was a mess. That was a mess. You just remember the parts that go well, and you fix things that went wrong with no record of your error. And that's kind of a beauty of dealing with a manipulative with algebra tiles. All right. Here's we're moving along. We're going to jump into the last bit of what goes on in 8th grade, and then we'll spend the rest of the time with high school. But and this is an overlap with Algebra 1. There's a few standards. There's few places where there's a direct overlap. Like 6th grade has their type of equations, 7th grade has their type, but there's something that is really kind of stated in both 8th grade and in Algebra 1. And because I'm going to need to deal with like actual numbers of people, all the way in the back far away from the door. Are you working with us as well?
So are you?
You're doing the math also?
I am.
Okay, great. Then we've got an even number of people in the room. I just wasn't sure when you came in that you grabbed some stuff. So I'm going to say all of the 4 people at the far back of the room, you are team A or group A for a moment. And in just a minute, can everybody flip to, in the packet, this page? It's just a page or so in. And you see just below the graph, there's something that says your beginning information. Is everybody there? You got it? All right. So the 4 front door people, you're going to need to close your eyes for a moment because I'm going to give them some information that I don't want you to have. Okay? You don't have to start yet. I'm just going to, let me pull up. I'm going to be ready with the screen. And just a second. Okay. So view. All right. Now, all of the 4 women closest to the door, close your eyes for a moment. 4 at the back, here's your beginning information. Please write it down. I'll give you about another 10 seconds. All right. Now we're going to reverse. Okay, women, you can open your eyes. Guys at the back, all 4 of you, could you close your eyes for just a moment? All right, the 4 closest to the door, I'm about to show it. Is everybody eyes closed at the back? Yeah? All right,
Yeah.
here's your information. Write it down. You got about 5 more seconds. All right, everybody have your starting information. All right, do you guys think at the back, do you have enough information to fill in a table, make the graph, and write an equation? Can you pick some values? I'm not asking you for actually telling me the values, but can you get some values that work with your given information?
Yeah.
Okay, how about up front towards the door? Do you have enough information?
Sure, yes.
Okay, so I'd like you to just fill in a good chunk of values in your table, make the graph, write an equation. You may confer with each other. And just make sure that you have a nice, clean, complete.
I'm just picking someone of the numbers or,
Okay,
like I did 2, 5, 7 for Xavier and
okay.
Yes.
then, it was starting out to. It's just kind of words.
I'm gonna go even.
Oh dear. Some very creative math going on here.
Okay,
Times
good.
14 is now 24, just so we're all clear.
I'm gonna do.
So everybody make sure you've got at least 6 or 8 points in your table and in your graph.
Okay. I know that's really hard to grab, though.
Here's a straight edge. Yes.
All right, and then only to the people that have the same information as you, make sure you take a look and see, is your graph really pretty identical to their graph? Even if the points are slightly different, the pattern should be the same, that you share some values in your tables probably, and that you've agreed upon an equation.
You got it straight. I guess I can do that.
Oh, yeah.
All right. Can I get kind of a visual thumbs up from most people? Are you there? I saw back table.
Yeah.
Yeah. How about that middle door side table? Are we about ready? Okay. Now, I'd like each of you from team A, could you make eye contact with someone from team B? And you're going to decide, so if they're not looking at you, there's 4 and 4. So make eye contact with who you're going to go talk to. If you turn out that you're walking towards someone and they've already got a partner, you accidentally misread the eye contact and you'll have to go find someone else. But this should match because I see 4 and 4. All right. So go talk to someone. You tell them about your information and your graph and your table. You ask them about theirs.
Okay, our goes to
Well,
yeah, well, we went out the same, that she's present, so.
I also didn't look at my main, well, actually, my main is
All right. Everyone pause for just a moment. Your attention.
I just looked like like, what is it?
Can I get your attention for just a minute?
This is such a great idea.
Here's a disturbing bit of news. What I told both of you is true.
So I did.
Just checking. Can you guys hear me? Did I lose audio? Hello? Hello? Did I lose audio? Can you hear me?
We're just being loud.
Oh, okay. Yeah, so thanks. Good. Can you hear me now?
Yes.
Okay. So here's a disturbing bit of news. What I told both of you is true. What both groups know is both true. Think about how that could be possible. Again, do a little comparison, look at what you did. But what I told each of you is both of them are true.
I opened the stocking on mutual Xavier. Oh, God. Funny that. Yeah, you want to find this one where.
You saw us twice.
You have two X?
Mhm. But they're gonna aim.
All right, does anybody, can anybody talk a little about, um, anything you thought of when you said, wait, do all of your, somebody from Team A, can you raise your hand? Anyone from Team A? There you go. All right, can you, give me the first point from your table?
24,0.
24,0. Team B, would you agree with that point?
No.
Okay, so this is disturbing because I'm telling you, what I told both of you is true. Does that lead you to any kind of conclusion?
Yes.
It's only true at one point.
Yeah.
Did you guys all find that point?
Yes.
Okay, can somebody describe how you found it?
So I just held up both of our graphs to the light and it looks where the lines cross.
Okay, can you show us how you do that? Can you go ahead and take, did you take the 2 pages off?
Like that, right?
Oh, there you go.
Did this, and then I can see the line underneath. And then I saw my line is.
Okay, did anybody else try it that method? Okay, try it. If you haven't done it that way, go ahead. Put your 2 papers together for a moment, those other teams, and see if it works for you guys as well. Can you actually see through the paper for a moment? There is a reason why I only copied that one-sided and I didn't put a backside to it. All right. Now, if those other 3 groups didn't do that, were you still able to find that important point?
Yeah,
How did you find it?
we set our 2 equations equal.
So you, you had 2 equations, right?
Yeah.
And what? A second, I lost my equal sign. What were your 2 equations?
2x and 24 minus x.
And 24. I'm gonna pretend. Okay, that's 24 and a minus x. All right. So you did that, and what could you do then?
Could, negative X on one side.
Yeah.
Both sides, same on both sides.
What can I do to both sides?
Add an x. Add an x.
Add an x to both sides.
Cancel out now.
And what do we have?
Yep. Yeah. And then divide it out to 8 equal pieces.
The 8 equal pieces. We'll say that my 24, I bet it would divide out to 8 equal pieces there. Excellent. So, but does that give you a point? That gives you a number 8.
For x.
For X.
And then with what you had in front of you, how did you figure out the point?
Because I had a table.
Oh, you had 8 on your, it was 8 something, was 8, 816 in your table already?
Yes.
It's also on the graph.
Was it in your partner's table?
It's on his graph.
Oh, it's on his graph. So you could look to the graph to see those. Okay, did anybody else find it any other way? Yeah, how'd you guys do it?
We just guessed and checked. So I asked what his Y value was for a certain X and then shifted and adjusted until we found one that matched.
Okay, did you happen to have that shared value on both of your tables or not?
No.
Did either one of you have it?
Yes.
Okay, so one of you had it and then you came to a conclusion that they agreed with it also. So what makes that 1 point so special? Okay, anything else? It's an intersection, but even without the graph, it would be special. What else can we say about that X and Y value?
It makes both equations true.
Okay, so what might be a good thing to call that thing?
A solution?
solution?
A solution. Does it look like solutions we've had before?
No.
No, it's a totally different kind of solution. It's got two values separated by a comma with some parentheses. It's a whole new definition of what does it mean to be a solution. Great. If you guys want to, you can come on back. You don't have to, I'll stay standing for that time. So let's take a look at then what we're dealing with from this list. What have we done in 8th grade? Let me just make this right size. Okay, so there's some big development in 8th grade. Let's take a look from this chart of all the things that we now have changed or dealt with sorry, I gotta grab the right thing to share. Okay, so you can see this again?
Yes.
All right, so look at all the things that happened in 8th grade. We now move from just specific forms of linear equations to any linear one variable equations. Variables are available on both sides. And so now we've got this major new development. Do we change what we're allowed to do to the equations though? From 6th grade?
No.
We're still only adding and subtracting, multiplying and dividing from both sides, but we do have to know how to respond when the results either come up 6 equals 6 or 6 equals 3, and be able to handle it. But the possibility of no solution has been introduced. But it's still true that if there is a solution, it will be a single rational solution. 8th grade does also offer, if you didn't know, they're supposed to solve equations of the form x squared equals something or x cubed equals something. And that introduces the possibility now of an irrational solution and one new set of operations that we're going to need for inverses. We're going to need a cube root and a square root to be able to solve those. In particular, why does 8th grade need that new skill, need that new type of equation?
Pythagorean theorem.
Right. So there is some coherence again in 8th grade. Why also does 8th grade need to have variables on both sides? Because now they are going to deal with
Never thought of that, but yeah.
systems of equations.
Yeah.
Come up with variables on both sides. When you put those systems together. And so there's some coherence about what's going on, but in many ways, 8th grade is a radical shifting of what types of equations are possible, what do we mean by a solution, what types of solutions are possible. And so there's conceptual growth here that is, I think, at times underestimated by many 8th grade teachers, that we're really shaking up their world. And does much of this overlap with what's going on in Algebra 1?
Yeah.
Okay, so we now in Algebra 1 allow variables on both sides. We allow the possibility of no solution, and we do systems of equations. I do want to bring up the possibility, and then I'm going to have you do some of the same things with it. Especially since you're a high school group. Can I ask, is it true also, as it is in California, that only 11th graders take a shared end of year math test?
Yes.
Okay, that's what I thought. And is the Desmos graphing calculator what is available on that test?
Yes.
Okay, that was my understanding that both of those are available, that both of those were true. What were our two equations for Xavier and UCell?
Y equals to X.
Y equals 2x,
And y equals 24 minus x.
okay? Y equals 24 minus x, although, did anybody write it a different way?
Negative x plus 24.
Negative x plus 24. Did anybody just write it x plus y equals 24?
I started out with that.
Oh, okay, because it seems like your beginning information just said together they have 24. So a lot of times students will write it that way. If I'm looking at this, I can see directly the solution. What's a way that someone just said we could combine those two equations?
2x equals
Yes.
24 minus x.
Okay, notice what just happened in the graph. So I've got a new line there. But can I finish solving this? What would be the next step that you said? The person who was in the back said how they solved it. What did we end up doing to both sides? Add an x, and what did we result in?
3x.
How can I tell from my graph that I'm still doing good work?
It's the same place.
Same line.
That purple just landed smack on top the green. What would be my last? X equals 8, and I'm feeling good because that landed on top. But if I wanted to, could I go figure out what y equals? Which equation do you want to use?
2x.
First one.
I'm going to say 2 times 8. What can all of is the picture really enforcing for me that all of my steps are good?
Yes.
And then what is my final solution then? 16. I can even ask for it to be labeled. All right. So here's a process. We might have people do something like this on paper, but why not also let them do it the same process using Desmos? Can I ask you guys, most of you have a device with you, right? A computer of some kind?
No.
Do at least half of you.
Sure, so.
Okay, could you and a partner sit down with each other and do the steps that I just did? Using just open up the Desmos graphing calculator. We don't even need an activity here. And can you start with these two equations?
We have a login.
Let's see. Well, it's
We're gonna have to have a login for them.
So you just have to go desmos.com and click on the graphing calculator.
I have to access the internet.
Higher level.
Yeah.
Ooh. I have to do.
My guess.
All right. Are we in good shape? One computer for each 2 people? And you sit down, and you can also solve this with your algebra tiles. So let's try and combine the two together. And I'll give you a moment to get that done.
In fact, I took a workshop that included quadratics. I have some quadratic uses. Now, that workshop did include those, but I bet he's got some other kids.
I'm just checking, is that working? That you guys can do that? You got a device between the two of you?
Yeah.
Okay. Because while I'm sharing, the picture of what's going on in the room is really tiny.
We just don't have a Wi-Fi password here for computers, so we're doing it on our phones.
Oh, okay. That is the beauty of Desmos. It does work on your phone as well. And one of you could also end up building it with the algebra tiles and solve it that way also.
Okay, so the first thing, when you want to add.
Yeah.
Around to that. Negative to it, or. Must be right. Would be equal to fraction of. And then use the negative.
All right, did you look at it both ways? Anybody want to comment on seeing that series of equations in Desmos and all the new lines dropping in? Have you regularly asked your students to use Desmos?
Every day, I'll take it without question.
Let me say, get a show of hands. How many people have students regularly use Desmos during the course? Okay. Have you ever solved a system of equations like that before?
Nope.
Okay.
Yes.
Does it feel like it might be, I don't know, educationally sound? Okay. What makes it useful? What might be some misconceptions students have about equations as they're solving them? That this would clarify is, or what should you think about each line in an equation as you're solving?
That you're making it look different, but it has the same value.
Excellent. So they may think they're actually changing something of meaning on the equation. They're changing something, and that in some ways they're creating the solution, as opposed to that the solution existed right from the start, that there is a solution there. We're just kind of, in a sense, exposing it. We're changing the form of the equation, but each of them are truly equivalent equations, and that we're slowly putting those together. There's also the significance that when you take those two variable equations and rewrite them so that there's only one variable, that you change it into this vertical line that is just telling you what x is. We don't know what y is, but it's giving you this vertical equation. Could this work if the two equations require more of a substitution into one that's in standard form? Could you still do it that way?
Yeah.
Yeah, like if we think about it, our equations, if somebody had started with x plus y equals 24 and y equals 2x, if you just substitute that 2x in for y, you just now have 2x plus x equals 24. And that would be a very friendly route to work your way through as well. So this ability to play with equations, it also eases students' minds because the solution is already apparent. You don't have to worry about whether I'm getting the right solution. They can just focus on, okay, things are going well. I've got feedback every step that things are moving along in a good way. And if suddenly a line not going through that point of intersection shows up, then it should indicate something went wrong. All right. All right. So we're right about halfway through, probably a good point. Why don't we take a short break? If you want to get up, stretch a little bit, why don't we just take 10 minutes and then we'll hit some of the bigger ideas that come up in geometry, well, more so building on it through into a lot more equation stuff happens in Algebra 2. So let's take 10 minutes and we'll start up again at, what is that, 1:55.
But yeah. It's just, there's more folks on like middle stuff. But which is not doing like middle math. I could have because I anticipated that a lot of my kids are in that level. That's what their math is still probably below that. Yeah. Right, which is a little bit, right, yeah, problem solve. Yeah. Nothing wrong with that, but it's also. I just. Yeah. There's also, I think the description of the classes. Because there was one that was a science-based one, that would have taken, but it did not seem science-based anymore. No, this one. Okay, we're saying, it had some weird words called. Oh gosh, I don't. Doesn't matter, I didn't take it. Very narrow.
Yeah.
And he like, he goes,
Put a dress on, no thanks. Exactly. But apparently it was a guy who's, great at getting kids to do science work and motivate them. Didn't sell to me very well.
They call it applied math, but what is it?
Why isn't there?
Yeah, and so we go through and we need to look at.
Or just some different.
Like, what should we be calling it? And what have we done? And it's really the 30, but it's whatever we have. Over the.
Yeah, where you got? Even if I was, I didn't draw it.
But then I also been probably. You need to have in your third year, I can decide that for two. Yes. If you're not. Which, their kids are having, do you? I don't know.
White would press on me.
So you would take. When you take under, yeah. And then you go, hey, you've done 3 years studying math. Yeah. And they'll never took away an credit. No, so they're getting full, It's not a good thing. Because now you go against is that you need to have this manufactured credit stuff. And those kids are getting 1 credit for the class and everybody else is still getting 1. So I had that conversation too, because I have seniors for advisory and you're getting through other credit stuff. And I'm like, this.
I don't know if I can or not, I'm just, that's what it appears to be, that's why. Thank you to understand, the QR code. They go around here, slip away. I've seen about going that goes.
Whatever it is. He's like, well, because they're going.
Sad.
And I was thinking, how? Like, in my mind, so you're doing the same amount of work.
I'm saying that.
So if it's a mistake, that was my issue, right? And that's what I'm about. So.
And then you want to. That's what I'm asking, integrity.
Right, so what I'm saying, and nobody's saying simply here, you're right, and the group, and like some of these kids' parents figure that out, you're gonna need to come in soon, and you're gonna lose. Because your teacher can really smell that for you. It's not a huge. One of those aggregates, it does come up. Well, and that's. You know, it's like, people need to call. They came in. So small. Right. I wish I had a better problem. You need to, that they, something else, like, you know, like, it used to be. Like, combined. And then this. I know, that's really, that actually got my, district. That's still doesn't mean. Like, these are supposed to be. What is the, is the majority of the jobs? The majority of the fractions. And I was working on this one, but in his lines of the conversation, like, I'm not trying to something around like really. Yeah.
There's a video that I get.
And this is what I did.
I think it's sick. All this. Yeah, this. So that is. Yeah. Regardless of what you call it. There's two settings, one of what you call it, another, should it count? Yeah, one, what do you call it, it needs to have a name, yeah, something.
Two, because some of my.
Should, are you teaching high school level, because if you're not, it doesn't work.
Yeah.
The minute you transfer those 3 years into an app credit, one of your elective credits is not an app credit. And does that mean that you're going to lose your finisher status in CT? Yes, it does. So why don't we not do this nonsense? Why don't I? Which I think we could prove you if we had those options for third year visa opportunity. I think what's going to holding people up is our own third year opportunity. And a lot of these kids they're facing and then you're pursuing great. Absolutely. They need to take advantage of it. And that's what they're letting more kids watch or something and come in that is not, which is also not. So I know it's learning a lot. Yeah. So I'm like, okay, I need to start doing some research for another third year class. And I think that Alicia had a curriculum. So people need to figure that out. Curious, I really done maliciously. It intends to help kids graduate, but it feels underhanded to you, and I don't think they intended it to be that way, but the result of the action. It's not how it's shown. It's like, it's how it's been done since kids are not graduated and giving extra. Exactly. Yeah. Let me ask you. Until some advanced kids figures out that they're getting one credit. Doing the school and then work, you're getting 1.3 credits. Oh, now it's something. And you start getting it from yeah, baby. So we're getting what happened. So I'm like, oh, yeah, that's not like her. You know, she was like, okay. She was like, well, you're not bigger, so that's why. But then it's like, I felt like I'm already kind of like between the sun and I don't know how much more to push the other things. Like maybe I should save some of my balance for like maybe next year's. I don't know if to Alicia that I have concern. I have been we do know that. I mean, the state's kind of there, like, no, the state knows that you're doing this. And Codes there can look at our side. Just like go back to these days. They're just in the class and they go, ding, 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 you took your tech classes, so they just add a class on. Is how they're doing it. I'm assuming is how they're doing it. And so then it just looks like your kids, they're like ambitious. They took an extra class. I just feel like it.
All right, let's carry on a little more. So we've now firmly left behind eighth grade, and there's three more major shakeups to the idea of equation and solving that happens in the first course of high school.
Another elective credit comes up. Then we'll be good.
All right, so in that first course of high school, Algebra 1, we shake up equations and solutions 3 more times. Could you go ahead and flip to the page that is called Making a Fruit Salad? All right. So go ahead, take a look at making a fruit salad. Our fruit salad today will be very simple but delicious. It is just a combination of pineapples and mangoes. So a very nice 2 fruits, but only 2. But we have a big crowd of people, so we're making a 10 pounds of fruit salad. Could somebody give me a combination of mango and pineapple I could use that will make 10 pounds?
5 and 5.
5 and 5, a good obvious choice. We're going to put, let's go ahead and put mangoes on the x-axis, pineapple on the y-axis, 5 and 5, that's a solution. Find a couple more solutions that you could do to match the idea of a 10-pound fruit salad of mango and pineapple.
2 and 8.
Excellent. Shout out a couple more. Everybody put them on there.
4 and 6.
Would it be reasonable to connect these points?
Yes.
Because do we have to state a whole number pounds?
No.
No, so we could connect points in between. And what should we call all of the points on that line?
Solutions,
Okay, solutions to what?
fruit salad.
To our fruit salad problem. Does our fruit salad situation have an equation?
Yes.
Okay, try to write it down and show it to the person next to you. What is the equation that matches our fruit salad problem? You might want to keep it in the most normal form of just what arises naturally to saying we need a total of 10 pounds.
What are we saying? Y equals.
All right, so what equation did you guys write?
Y equals 10 equals Y equals X.
I'm sorry, somebody say that again?
X plus Y equals 10.
X plus Y equals 10? That comes directly from the meaning of the situation, and it kind of makes sense. If any of you wanted to kick one of those over to the other side, it could be Y equals 10 minus X, but that doesn't feel like what we were doing. We were finding numbers that added up to 10 rather than we could find some specific ones that way. All right, but what's going to happen? So these are solutions to our fruit salad problem, but they are also solutions to the equation, right? So so here we're using the word solution more like we did for a system of equations. A solution is an X and a Y. It's not just a single number. All right. But what's going to happen with this fruit salad?
There's a domain that you have to consider.
No, I was just thinking like what happens to a fruit salad?
It gets eaten.
It gets eaten. Parts of it get, so I was going more for the real life situation, but you're right. We could consider the domain, that really our numbers could only go from 0 to 10 on this for either pineapple or mango. Although it's hard to call it a fruit salad if it is just 10 pounds of mango.
Yeah.
But nonetheless, we'll allow that. But now
A mango
turn to the
salad.
second page.
A mango salad.
And in the second page, we talk about some people have eaten something. We don't know how much has been eaten, but some have been eaten. What are some possible situations that could be left?
All the pineapple's gone.
Okay, if all the pineapple went, but how many mango could be left?
All of them.
People pick
Which would be how much?
Oh, the total minus however many pineapples were in there.
Can you give me a point, a number that makes sense? Or actually, two numbers, a pair. If there's some mango left, but all the pineapple's gone.
4-0.
4-0, is that a solution to this new situation?
Yeah.
We had some miners who dug out the pineapple and left the mango behind, although I would go the other way personally, but nonetheless. So 4-0, what are some other numbers that work? Okay, what are more?
3.50.
3.50. Do we have to have zeros? Can
They
somebody give me a
all
point without a
have-
zero?
You have 1 pound pineapple, one pound.
There's one pineapple left underneath.
Yeah.
A 0.25 is left underneath.
Okay,
You
so
just
we could
got
have
it.
1 and 0.25. Start plotting those points down at the bottom there. Could you have 4, 5? Would 4, 5 be possible?
Sure.
How about 7-2?
Yes.
How about 6-1? Okay, is this going to get tiring trying to plot all the points?
Yes.
Yep.
Okay, so think about on the backside, we drew a line to connect everything that was possible. Think about what are you going to have to do to show what are all the possibilities here.
All of the. I'm back in algebra again.
So how are you going to show it on your graph, all of the possible solutions?
We're gonna shade it.
Okay, and this could lead students to do something that maybe we would have just told them what to do, to just shade something. But if you're saying, if I'm putting in a dot here and a dot here and a dot here and a dot here, and I'm going, all of these, let me zoom in a little bit on that. So if I'm putting all of these, but I can't go past, I went, hey. So I could kind of draw, okay, I know something's been eaten. I put a couple of dots there that are bad, so we'll, not that one. Those are not solutions.
They're outliers.
But all of these start becoming solutions. And I start saying, okay, that gets tiring to try and put all those dots in. If I know strictly that some have been eaten, what should I have done to that line?
Dotted it.
Yeah.
Yeah, and maybe say, I don't really want the exact line, so I'm only going to just do kind of like a partial line, like kind of a dashed line that kind of shows this is my boundary, but not all of those. The only thing I'm trying to draw attention to is this is a conceptual leap again to say that the solution is not just a point or even the points on a line. It's all of the points in a whole region that are all possible. And that's something new. So that's one leap that happens. Do we know, do they do any of that in the middle school?
No.
That's good then. Sure. I'm glad the middle school person could say that because the high school people need to know that. If your high school students come in not knowing that, should you be upset?
No.
Okay, so sometimes high school people get upset about things they think other people should have taught them before. But inequalities in the plane are not part of the middle school curriculum. So you have to expect that they're not going to know that. Nobody would have taught them that. All right. Let's take a look at the next couple of weirdnesses that happen. And we'll look at two more, and then we'll look at our chart again, just to see how things are developing. I'll give you it's not that long, maybe a minute and a half to browse down this page about the zero product property.
The only way I've ever been able, and I still can't, I still don't want to really actually explain it, because I'm not sure, but I totally have a grade. I just know that when I do like 2 cubed, 2 squared, 2 first, 2 0, and do the negatives, the only number that fits in the pattern is 1. So, but I can't really explain it to them other than to show them that pattern.
All right.
Oh, yes, that's right. Mhm, it is, yeah, you're right. And I have shown that before. Yeah. Mhm.
But they see it, they don't ever see it that.
Yeah.
All right. I think most of you, I'm sure, know the point that if things multiply to make 0, the only way to get that is one of them to be 0. But what I want to draw attention to is in this chart, and to remind you of what the chart really is at the top, we've got the idea of equation, we've got the idea of solution, and we have methods for solving. What is so radically important, and what is going to change? Will we change the idea of equation? Will we change the idea of solution, or will we be changing our methods for solving based on this? Check with somebody next to you. This zero product property is massively important for one reason, and it's a question I'm asking you: is it because it changes our idea of equation, our idea of solution, or our methods for solving? Which one makes a radical shift in this unit that we would be working on? Talk to each other. Which one has been changed?
They have to understand, if they never know something like understanding the solution. Thinking that's right, so that pretty concept. Yeah, I think it's easy, so is
All right, let me ask by a show of hands. How many think this idea of the zero product property will radically change our idea about equations? Will it change the idea of solution? We got one vote for that. And will it change our methods for solving? Now we got a couple of votes for that one. All right. Either of you want to justify this? When I now look at this equation, what does it mean to be a solution?
So the reason I said solution is because, like, we were talking about, even in a system of equations, having a solution that could be a y. And the zero product property talks specifically about it being an x-intercept and always an x-intercept. And so it changes what a solution is and why it's important. And so that's why I said it changes the concept of what solution is for students.
Excellent. So you're saying we're changing the implications of this solution are more than just the old one. What was our old idea of a solution?
an answer to,
Value that.
value that makes an equation true. And
Okay,
now it has more to do with like a graph and like there's more things that it has to do with.
okay, so it doesn't give up that old meaning,
Right.
but it has more layered meanings on top of it.
Yeah, so that's why I said the solution part.
Okay, and in the back there, I saw 3 hands go up to say it's significant because it changes our methods. How do you mean that?
Well, it doesn't necessarily change our method. I think it adds a method, because you can still kind of use a graph them, you can still try some of the algebra stuff that you know. I mean, of course, you're gonna kind of run into some problems, but now you can look at factoring and using the zero product to find those x-intercepts. It gives us another tool.
Okay, I think it was okay that you were saying, when you first said it might change, because what were the old ways of solving? What was our main ways of solving? What do we do in all of these?
Add, subtract, by.
Yeah.
Add, subtract, multiply, or divide to where?
Both sides.
To both sides. Then we added in, you could do a square root of both sides. That's fair. Okay, but those are all do something to both sides, right? So if someone is looking at this problem here and they're paying attention to their old way of doing things, what would seem to be a reasonable first step?
Add 6 to both sides.
Add 6 to both sides. And we have to accept that's not an unthinking error. That is a very thoughtful person applying what they have known as being the only methods that we have. They might also want to try and do a square root at some point. And that would be a reasonably thoughtful method. And we have to say, we are pulling the rug out from them, under them completely and saying, no, forget about inverse operations. Don't do that at all. Just play with one side. And so what should they do to the left side?
Factor.
Into?
2 binomials, x minus
What are they?
x
X.
Minus
3 plus 2.
Okay. Now, is that a normal step from any other stage of dealing with equations? It's absolutely radical. It has seemingly no purpose. What's the next step after that?
Set them both equal to 0.
Separating it into 2 equations? What kind of craziness is going on here? This is not normal. And if we pretend that this is just something layered upon the old stuff, I would say, when you said at the back, it's not really something different, I'd say absolutely, no, this is radically different. And it's only after we separate it into this that we now say, oh, now think back to what you used to do.
Yeah.
Now you can go ahead and do your inverse operation. But completely ignore what you have always done for how many years?
That's so
A
true.
lot.
If they're in high school now, they've done it for at least 3 years, where the main strategy for solving for an equation, for isolating a variable, is use inverse operations. People probably had them saying the words, isolate the variable, use an inverse operations, do the same thing to both sides. They might have said that thousands of times over 3 years. And, and now you say, no, just factor the left side, split it into 2 equations. It is a radical shift. So that's one of 2 radical shifts here. I don't know, but after drawing attention to that and saying we might at least want to say something about what's going on, as you said, what's the meaning of this shift, that if we had this equation in Desmos, what will happen if I just type in the equation 0 equals our equation that we had there?
You know, line out 0.
0 equals, what was it? X squared minus X minus 6. What will I have? What will Desmos do to that? You think it'll make a parabola? How many people think a parabola is going to show up?
No.
I don't know what we'll do. Probably 2 points, 2 lines.
There it
Yeah.
is, 2 vertical lines. All right, and then what will happen if I factor that?
The line will stay.
Yeah.
But I will have X, what, minus 3?
Yeah.
That's one of them. And what's my other one?
+2.
There, oh, first I could just keep it as I have 2 factors that are on the same one. Now blue landed on both of them. Now what'll happen if I separate them? Get a green one on one, and I get
That's just what we were talking about.
Yeah.
X plus 2 on the other one. All right, so now we've got this this process of saying, oh, okay, Desmos is taking 2 lines and separating them into each of their own lines. And I couldn't tell easily in the first one what those lines were going to be, but now I can see them both. Okay. So a continual use of Desmos, it's what we know about learning a new concept, and this is what we're doing. We're shaking up their concept of, well, of even what does it mean to hunt for a solution. So we're changing that whole idea there. Multiple representations that we talk about and use language, talk and write about, is how we change concepts, how we develop them. And so that's pretty critical. So that's one more shakeup. And let's look at the other one that still happens all within Algebra 1. Can you guys flip the next page and go to the thing said a formula to solve quadratics? All right, so just let's mainly focus so that we have enough time to get through the last ones that are involving algebra 2. Do we have a formula that works for perimeter?
Yes.
2W plus 2L.
2W plus 2L? Why do we write formulas?
To have a generic form we can use for multiple situations.
So what is good about having a generic form?
It applies to multiple problems.
Okay, so you can apply it to problems quickly and easily. Anything else?
You could program a computer to do it.
You can program a computer to do it. That's an excellent, good, more modern reason. Formulas have existed longer than computers, but now we've got another good reason to use it. Maybe sometimes they're an easy way to convey information about how do you do a problem. All right. So if we've got that, let's go to, on the second page, could you go ahead and quickly solve all 4 of the top ones, but don't actually divide anything. Leave things in a fractional form. So you're going to solve 4 quick linear equations. If you notice a pattern, you should be able to do the third and fourth one even faster than the first and second. All right, let's go around the room. We'll start back middle. Give me one solution. I'm sorry, which one?
Number 1.
And what is X?
-7/2.
-7/2. Okay, door side middle. Give me another one, any one you want.
3/4.
For which one?
Number 4.
Okay, 3/4. Okay, front table.
X equals -1/3 for number 2.
negative 1/3, one of the back corners,
6/5.
6/5. All right, did you have to do any calculations? No, so can you give me a general solution for equations of the form bx plus c?
Negative C over B.
Negative c over b? Okay, could you quickly solve the 4 equations in the bottom just using the formula? What might we want to read that negative c as rather than negative c? There would be a good word that we can use instead of negative that is often helpful.
Opposite.
Opposite, because sometimes if you see a negative and it's already negative, that bothers people, but the opposite is a nice way of reading it. So we could say our formula is the opposite of c over b. Okay. So which one of these is the hardest to apply it to? Or at least the most likely of causing error?
Say D.
D, what should x be here? What's the opposite of c?
2.
2 over,
Negative 1.
okay. And that could bother people because sometimes they'll just call it negative x at the bottom because there's no number there. They'll just throw an x in there. Has anyone ever taught you the linear formula for Southern equations? That it is the opposite of c over b?
No.
No? That isn't a regular part of our curriculum? Does it work? Okay, why don't we teach the linear equation formula rather than, why don't we teach that? Talk to each other for a second. Give at least 2 good reasons why we don't teach that.
Specific to one case, the general.
And you're already going from concrete to abstract just by doing equations, so then to make the abstract of the abstract. Because a little more.
All right, let's see if we've got some. What's a good reason? I mean, I do this with students. I show them this and say, so how come nobody ever taught you this? Why doesn't this make your life better? Why did we not teach it? What do you think? Why don't we teach this?
The narrow field of application.
Okay, it's only good for equations of the form.
Bx plus c equals 0.
Okay, so it's only one type of equation that it's good for. All right, so that's one reason. Any other good reason?
Just like you said, the negative C makes kids uncomfortable, maybe?
Okay, it could lead to more errors than it helps. Yeah, it could make people uncomfortable with that.
Well, I mean, I don't know about everybody else, but when I put something like x equals negative c over b, they have a hard time memorizing those formulas, and they're gonna spend a lot of time memorizing formula for a very narrow application.
Okay, so it's more
Solving are more important and more applicable to a wider variety of problems.
okay. So it doesn't solve enough problems for us. Memorizing it may be more trouble than it's worth because it doesn't shorten things up very much. And so we come up with formulas when they serve us because they do more good than they cause us trouble trying to remember it. All right. So was it that hard to solve the top 4 without the formula?
No.
Okay, so it didn't really add all that much to our ability to get through things. Did it shorten your time all that much?
No.
No, so it didn't add that much, and it's just one more thing to remember. Now, what if instead, in order to solve this equation, you had to do all of these steps? Okay, and you have to do all of those every time you wanted to solve a problem.
You know,
And then you might be hunting for something that would allow you to do it just once and be done with it. And to
Yeah.
say, okay, I do want a formula for this. Because well, we could go through and talk through what is happening in each one of these. Does it feel messy?
yeah.
Okay, and that's why it ends up with a complicated formula, but still we could understand it and use it. But we don't have to then do all of those steps because the formula does something for us. How does this compare to any of our old methods for solving equations?
More complicated.
At first, it appears more complicated. Is it using any of our old strategies?
Kind of all of them.
Well, no, I mean, just using the formula, does it use? If we just go directly and use the formula?
I mean.
Oh, well,
Maybe.
minus C over A.
At this point, there may be some stuff in geometry that they should relate to.
I mean, it started out with the same two steps.
No, he's saying, once we get down to the formula, I think.
Oh.
I guess I'm asking the question, so looking at that equation, let's see if I can make it big enough. It's from the next page.
My question would be like, why would you use that when I can factor that?
Yeah.
All right, so if we're looking at our equation, old school, 6th, 7th, 8th grade, we might want to try and add or subtract something from both sides. That was a strategy, doing square roots, dividing, doing those things. And now we've taught them also, you could factor and break it into two other ones. And now we're saying, wait, why don't you just throw all of that away and just use a formula? It's another radical shift in the sense of saying it is it's a strategy completely new compared to all the other ways of doing that. Does anybody have any? I'll let you take a guess and confirm with the person next to you so you can have bragging rights. When do you think somebody came up with this formula? Here are 4 choices, rough times in which you might want to think. So how old do you think is the quadratic formula? So talk to each other and claim one as yours. What do you think is when you think this started?
Before we call it, but they don't call it. It's BC more, because that religious references. BC and more.
Did not realize I'm commonly heard.
All right, let's see how many people are voting for A. We got 2. I'm sorry, no quadratic formula back then. They didn't really use much of variables or do things like that. They did play around with quadratic equations sometimes, and they tried to find solutions, but nobody had a great organization. All right, who voted for B?
I'll say B.
Yeah.
And which part of the world do you think might have been doing that?
Like,
Latin.
no,
Roman.
I would say like.
Greek.
Somewhere over there,
Mediterranean area.
Yeah.
All right, you are partially correct in that they had almost a complete formula, and it was basically the Islamic world, the Mideast, that was doing some good. It's like where we get our word algebra from. It's an Islamic word, but they didn't accept negative numbers then. So all of their equations had to deal with, their formula wasn't general enough. Their formula wasn't general enough to accept negative numbers. So you couldn't find all of your solutions. You had to basically force things into different forms where you only had positives, but it was pretty close. Anybody vote C? And who do you think, and where do you think that's happening now?
France, England.
Excellent. We are in Europe by now, and you are talking about Descartes. And yes, we've got a very pretty much a finished, almost completely finished version of this, but it took into account negatives, and you could find all of it, although it took basically more into the 1800s before it took on exactly the same form that we have it, but they definitely had it by the 1600s there in Western Europe. So
Did they have imaginary solutions?
They knew of them, but said those are completely worthless. We might as well just call them non. They said if they are imaginary, we for all practical purposes should say they have no solution. People hadn't come up with any good reason to play around with an imaginary number yet, but they accepted that somebody had talked about it, but they were still like, I don't think that's worth anything.
Descartes was the one who coined the term imaginary.
Yeah, the kids still feel that way.
So in a sense, he was like, yeah, but I'm throwing it away because it really doesn't do anything for me.
So then you're going very complex.
Yeah.
All right. So just going back to our chart then of what do we have and what's going on. We've made some big leaps in Algebra 1. That's part of the reason why Algebra 1 is a crazy complicated course. It does a lot of stuff. You continue to do that 8th grade stuff, and especially the systems of equations. But you now do inequalities, including systems of 2 inequalities. I didn't bring an activity because there's just not that enough there's too much for the amount of time we have. But Algebra 1 also adds in the idea that you can do exponential functions. And you might ask the question, well, where does this exponential function reach something? When will this rabbit population get up to 1,000? What would be the only way students could solve that equation in Algebra 1? Yeah, did somebody mention the graph?
Yeah.
Yeah, that's really all they're stuck with. Why? What are they missing that they can't solve exponential equations?
They don't know how to do logarithms.
Right. So that's one of the most unusual situations where we introduce a function, but we don't introduce the tools for being able to solve the equations that arise until 2 years later. It's just an oddity in the math sequence of things that when you introduce quadratic functions, you also learn how to solve them. When you introduce linear functions, you do know how to solve them. In Algebra 2, we will introduce rational functions and solve them, trig functions and solve them, radical functions and solve them. But here in Algebra 1, we introduce exponential equations, but we do not know how to solve them, and we don't introduce. Not that I'm advocating that we should also add one more thing into Algebra 1. It is already a very hefty course. But for quadratics, the main idea here is that we introduce a radically large number of new solution methods. You can do factoring. I'm not a great advocate of doing lots of completing the square, because if you can factor and do the quadratic formula, not too many people whip out the completing the square when they need to solve a quadratic. The only thing that geometry adds that is a new type of equation are trig ratio equations. What do you need to learn also then in geometry? What new inverse?
The inverse is small range of students.
So you need the inverse of? Inverse of sine, inverse of cosine, inverse of tangent, because sometimes you'll want to solve and find a missing angle. And so that would be a possibility to deal with that in geometry, which would be a new tool. All right, so we're all the way up now to Algebra 2, and we're going to look at something strange. And I would like you to keep track and decide, where do you think there is a logical flaw? I'm going to prove to you, and I had this proved before, that 1 does equal 0. Can you accept that we are going to start the problem with x equals 1? So how much is x equal? 1. That is just a true statement. I'm saying for this problem, x equals 1. And if x equals 1, would x squared then have to equal x? If x equals 1, does x squared equal x? What did I do to both sides?
Multiplied by x.
Am I allowed to multiply both sides by something? Is that a
Yes.
standard back all the way from 6th grade?
Yeah.
Yeah, okay, so I did that. Now, what did I do between step 2 and step 3?
Subtracted one.
Is that an allowable statement?
Yes.
Okay, nobody's bothered by it?
No.
Good, because we've been doing that. You've subtracted 1 since the very couple of minutes we started this session. We've been doing it since 6th grade. Now, this is taking advantage of something from Algebra 1. Can I rewrite a quadratic as factors?
Yes.
And are those the correct factors?
Yes.
Okay, so no logical error there?
No.
Okay. Now, what are the 4 things I'm allowed to do to both sides?
Multiply and subtract divide.
Okay, I'm just going to divide both sides by x minus 1. That is the same expression over itself, so that's a 1. So x plus 1 must equal 1. Okay, and because this would just be a 1 times that, and 1 times x, and 1 times 1 is just x plus 1. But if x plus 1 equals 1, then x must equal 0. Isn't that true? If x plus 1 equals 1?
Yeah.
Okay, but what did we start with?
X equals 1.
And now x equals? Then the only logical conclusion is that 1 equals 0.
No.
Okay, so talk to each other. Do you believe this conclusion to be true?
No.
Okay, I'm glad. When I look at my classes and sometimes they go, well, maybe, and you're like, no, 1 does not equal 0. That is not true. Even though I've proved it to you, that should not be true. You must now try to talk to each other for a moment. Where do you think there might be a flaw in my logic? Because there must be some kind of flaw if I get to a conclusion that can't be true. So talk to each other for a moment and see if you can come up with a reason. How did such a result occur?
Right, it doesn't matter, it's right here, yeah, he wants in one position, so there's 2, one works and 0 works.
Yeah.
But I can't explain why that's a logic fallacy though, because you are allowed to multiply by x.
If that's what you need to remember, it's worth 0.
So there needs to be a rule applied.
You're right.
Because 1 is the universal.
Yes.
It's like when kids say that 1 is prime.
Yeah.
No, 1 is universal.
Yeah.
So if it only works because 1 is a universal number for every base.
Yeah, you're right.
So that's.
So that is why. Because 1 times anything is itself, everything with the proof is it has to work for everything. Yes.
So
That makes sense.
you put anything.
All right, let's see what we've got here. I'm not going to ask for the exact reason just yet, but we've got from 1 to 2, from 2 to 3, 3 to 4, 4 to 5, and 5 to 6. So if we're talking about 1, 2, 3, 4, 5, 6, It's the in between 1 and 2, 2 and 3, 3 and 4, 4 and 5, or 5 and 6, where something funky must have happened. Somebody want to tell me where they think something wonky went on?
Well, there.
1 to 2.
So our first candidate is between 1 and 2. Does anybody have any other candidates for where something wonky went on?
0 and 1.
Between 0 and 1, there was no 0. I just started with x equals 1.
We didn't.
It's okay to start with the problem and declare for this problem x equals 1. But so we've got a question about here.
Yeah.
Okay. Does anybody have, are there any other places we should be concerned about? I'm just going to draw attention to, say, in this middle stage right here, would 1 still work?
One minus one, 1 minus 1.
Is that the only number that works there?
No.
What other number could work?
0.
So at stage 3, both 0 and 1 works, correct?
So at 2 though.
Okay. How about down here on stage 5?
Only 0 works.
Only 0 works. Okay. How about up at stage 1?
Only 1.
Only 1.
Only 1 works. So we went from only 1 working to both numbers working, now to only 1 working. In a sense, if I'm a magician and I put a rabbit into a hat and pull out a pigeon, what are the 2 things I must accomplish?
Right.
Getting rid of the rabbit and getting the pigeon.
Exactly. Okay. I've got to get rid of one thing and get the other thing. For a moment, there might be both of them in the hat, and then I got to get one to disappear and the other one come back. So how many things are in the hat right now? I mean, how many things do we've only got only a 1 now. Okay. By the middle of this magic trick, I've got both a rabbit and a pigeon. And by the end, I've only got the pigeon. All right. So I went from a rabbit and a pigeon, and then only the pigeon. So something funky must have happened first, but something funky must have happened also along the way here. So there's got to be somewhere else. If you flip in your packet, there's a little clip out of a Wikipedia page about extraneous and missing solutions. These are both topics for an Algebra 2 class. They probably should show up in a pre-calc class as well. So could you read for a moment something about extraneous and extraneous solutions? And see if we can put to words. And then on page 3, there's a little thing about missing solutions. And see if we can clarify what is the weirdness that we did that got an extraneous solution into the problem and then made the other one disappear. So you want to look a little bit on page 1, 2, and then 3.
And it's, it just makes sense, it's anything that's not invertible. Which makes sense because he basically, yeah, it's not a I expression.
But the next time,
An expression that you declared by the given statement is 0. That's when math gets broken. That's what I call illegal math.
Illegal.
All right. Does anybody have some language from the article that'll tell me what happened between 1 and 2 And what did it do using language from the article?
Says that when you multiply both sides by X, it multiplies both sides by 0.
So multiplying by X, it doesn't necessarily multiply by 0, but X could be.
Yes, could be 0.
So what does multiplying by X do? What does it introduce?
An additional solution.
Introduces
Introduces
a
a
new,
different,
maybe extraneous
yes.
solution. Okay, in effect, I had a rabbit, now I've got a rabbit and a pigeon.
Right.
Okay, but that doesn't end the magic trick, because I've got to get rid of the rabbit to make you think I turned the rabbit into the pigeon. Okay, so this is the step that adds a new solution. Multiplying by X is sometimes useful in solving equations, but we need to be careful that sometimes it makes new solutions into an equation that didn't have it before. It's called introducing an extraneous solution to the original problem. Okay, can anybody figure out, how did I make the rabbit disappear?
Divided by a term that could be 0 based on the given statement at the beginning.
Okay, so now I'm dividing by another algebraic expression. And is X minus 1 something that just could be 0?
It is 0 based
It
on.
actually is 0, because I said I knew X equals 1. So I'm now dividing by 0, and I'm making a good solution go away. So
Right, which was
by
an
X
excluded
minus
value.
1
We just didn't see it.
Yeah.
makes the solution that was a valid one, the solution X equals 1, disappear.
He was just so convincing, we didn't see it.
All right. So so what is the takeaway? When do you have to be careful? When you multiply by variable expressions, and when you divide by variable expressions. If you multiply or divide by a whole number, will that cause any trouble? So multiplying both sides by 5, totally valid. How about multiplying both sides by a negative number? Is that okay?
Yeah.
Okay, so those are okay. So these are the places that cause issues. Can you see on the next page after the 1 equals 0, there are 3 equations in the middle. Okay, do you think any of those equations might make you want to multiply by a variable expression on both sides?
All of them.
Okay, along the way, if something comes out, they may draw you into dividing by a variable expression as well. There's a certain problem that might make you want to do that, particularly the middle. So what I'm going to ask, let's say front 2 people, pick one that'll be your equation, and you have to decide if anything wonky happens. Which one do you want to do? For A, B, or C?
A.
Okay, they take A. The middle 2 on the left and my one guy on the back right behind them. You get to pick another one. Do you want B or C? Which was it?
C.
Okay, so C, that leaves my middle 2 in the back and the guy further back by the refrigerator. The 3 of you, you get B. Go ahead, solve them, and keep an eye out for if anything wonky happens along the way, or whether something could happen that is wonky if you're not careful.
If negative 1 is an excluded value.
Yeah, the only thing I'm thinking of quantity that's happening is that we're going to factor this top part. You know what I mean? And then try to do some weird, like, kind of factoring.
Yeah, definitely.
But other than that, I feel like it's a pretty straightforward question. Because there's not any, other than the biggest mistake I see happening is multiplying. I don't want to know within my mind. Distributing to the first term, not the second, that happens all the time.
Yeah.
But other than that, I feel like it's really just a question.
Yes, we can't do that. So it does work.
So the only, yeah, that's how I'm like, okay, the only funky things would be not distributing quickly. Or trying to factor and trying to do like, oh, 9 and 3, yeah, 3, you know what I mean, like try to do some weird.
Or I guess I could also see, just because we're working on this with much simplified equations, but like, because we're doing. Yeah. Let's try to. That's how we use, guess what I'm doing. Yeah, something like that. And then we go times 2. Times 2, and of course, this is good. But then they want to
minus 2 where x.
they want to write like this, because they see this and they go.
Yeah. It's all for x.
Oh, yeah, they times the top and the bottom.
Yeah.
Yeah, I see that all the time.
Where, well, once they distribute, they, I guess they write like this.
Yeah,
They go 2 divided by 2
So they
is
times-
1,
yeah,
so
they
that's
times-
1, and then also 2 times that.
yeah, so
All
they
right.
actually change the whole problem.
Yeah.
Have most teams solved their one equation?
Yes.
All right.
Tell me, if you did something like that with your times x plus 1 here, you could, but
Let's
that's
see.
not, it's not a problem, it's a matter.
Yeah, that's a big
Let's-
number.
Yeah.
Let's go ahead then, and anybody want to volunteer to start with, and we'll take, well, actually, I think it's worthwhile to start with A in this case. So let's take a look. A, what options do you have to start this problem?
So we felt like it was a fairly straightforward problem. I mean, aside from maybe putting a 1 underneath 9 and talking about it being a proportion and cross multiplying or something.
But either way, what are you going to end up multiplying both sides?
Multiplying by x plus 1.
Do you really have any other choice?
No, and so we were saying the only real mistake would be just faulty math, like only distributing the 9 to the x and forgetting to distribute it to the 1, which is a common math mistake.
Okay, so, but I want to be clear that we're multiplying both sides by a variable expression, not just because we want to or because it's an option, but we really don't have any other choice.
There's no other way to solve it.
Okay, so does that mean multiplying both sides by a variable expression is a bad choice?
No.
No. Now, it does have risks under some circumstances. It doesn't play out here that there's any significant risk, but we need to know that this is an actual useful tool that has dangers that don't always realize. If it was always going to do something wrong, we wouldn't use it as a tool.
Right.
But this just turns into 9x plus 9 equals 6x plus 15. Is that a pretty, what grade level equation is that?
8th grade.
And we just get 3x equals
6.
6, so x equals
2.
2. And does that turn out to be an actual solution to the problem?
Yes.
Yeah, so we've got no issues here. It feels like this is comfortable. Things are going well. All right. Now, team B or C, whichever one, who wants to tell me what you did?
Yeah, all right, so team B.
All right, what'd you do?
We multiply both sides by x minus 2.
Again, does that seem like a reasonably good choice?
Yeah, early choice.
Right? We needed to do that. Now, the question, when you see this, do you have anything that tempts you?
Dividing by the.
Yeah, I mean, we want to divide by x plus 1.
Okay. A thinking student might go ahead and divide by x plus 1. If you did that, what would be left?
X minus 2
X
equals
minus 2
5.
equals 5.
X minus 2 equals 5, so x would equal
7.
7. And you might feel very good about yourself, and you could go back and check, does 7 work?
Yeah.
Okay, what is there anything disturbing about this though?
Yes.
Well,
I was trying to find X over them. This is section 8.
We divided by a variable expression. Would that typically introduce a new solution or possibly get rid of one?
yeah, I mean, along the way, we look at the zeros on the bottom, 2 and then -1.
Now, did we have any other option at this stage?
Yeah.
What could we have done?
Multiply.
And that would be what, x squared
Minus x.
minus x
Minus X. Minus 2.
equals 5x plus 5?
Yeah.
And if we bring that over, what do we get? X squared
Plus
minus
4.
6x
6x.
Minus 7.
minus 7. And do we have factors?
Yeah. Minus 7 and plus 1. So you
So
do
x could equal 7 or x could equal
Yep.
-1. Is -1 actually a solution?
Yeah.
Yeah, no, because again, if you do it the other way.
Well,
Yeah,
let's
it
try,
is.
go back. Does -1 work?
Yeah.
Yes.
0 equals 0.
Neither of those is undefined, right?
Right.
Right, I mean, this is gonna be 0 over -3.
Yeah.
And that's just 0? So is this one solution or 2?
2.
2.
Okay, so it distinctly has 2. If we look for a shortcut here, we end up getting rid of a solution,
Yeah.
okay? That's one of those cases in which the most observant student causes themselves trouble rather than, you know, someone who just goes, I guess I got to multiply, and they just go ahead and do things, and you get 2 solutions. So, so what is that again? If you multiply by both sides, what's the risk?
You can get rid of the plausible solution on accident.
No, if you multiply both sides by a variable, you might bring in an extraneous one. But if you divide both sides, you might
Eliminate.
Eliminate one.
eliminate one. So there's 2 twin issues about working with variable expressions, either introducing extraneous solutions or eliminating old ones. All right, the team that did C, how might you begin this?
We factored the top quadratic first,
You factored the top quadratic, and what did you get?
x minus 6 and x plus 2.
And what do you have?
Well, we simplified the left-hand side, because x plus 2 over x plus 2 is 1. 1 times x minus 6 is x minus 6.
So x minus 6 equals 2, so x is 8. All right, did they do anything that might introduce a problem?
Divided.
Did you divide both sides by a variable expression?
No.
Not technically, no.
No, you didn't. It was already there. So you just simplified an expression. So there really should be no issues. How might this problem become an issue?
If
What's
you
the other option for starting?
multiply each side by x plus 2.
Multiply each side by x plus 2, and you would have x squared minus 4x minus 12 equals what?
2x
2x
plus 4.
plus 4.
2x plus 4, and
Yes,
then x squared, what?
Minus 6x minus 16 equals 0. Factor.
That does factor to what?
You get x is equal to negative 2x equal to 8. So x plus 2
X plus 2 and x
was 8.
minus 8.
Yeah.
And that would give me two solutions of x equals 8 or,
X is negative 2, but the x equals negative 2 doesn't check when you put it back in.
Yeah.
right, what did we do when we multiplied both sides?
We introduced an extraneous solution.
We introduced an extraneous solution. So this problem, you could begin by multiplying both sides and work things through, but did you have to?
No.
No, this one, that was your only choice. It turns out that probably wasn't the best choice. Factoring and then finding a pair worked better because it only gave me one solution and only one of these is right. Here we have extraneous solution that, I don't know if I'm still writing in a place you can see, because I zoomed out a little. So we got the old extraneous solution, if we do it that way. So why don't we ever talk about these before Algebra 2? Under what circumstances do they come into existence? What types of equations? Anybody got a name for it when you got those expressions down at the bottom?
Rational? Yeah.
Yeah, they're rational. So we don't solve rational equations in Algebra 1 or lower grades. So there's no possibility of introducing an extraneous solution. Nobody in Algebra 1 is just going to say, boy, this equation is too simple. Let's multiply everything by x. You're not going to just accidentally introduce an extraneous solution. But it is part of the standards for Algebra 2 to understand how they can occur and then to be careful of them when you do it. The other place they can come into existence is
Radicals.
Is in radicals. Okay. So, and that's our last peek at things. And I think it's cool to look at that from a graphical standpoint. What does when you see a system of equations, we often put them together into one equation, right? But oftentimes it's nice as we get into advanced mathematics, if you see a complicated equation, to just break it into two parts and look at it graphically. So if we're dealing with this funky equation right here, the square root of x minus 3 equals x minus 5, could I think about it as a system of equations?
Yeah.
Go ahead and write on your paper, what two equations could we think about it as if we broke it into a system?
Equations are a lot easier to graph than.
Okay. What are our two equations?
Y equals square root of x minus 3 and y is equal to x minus 5.
Okay. One of them's fairly friendly to graph, x minus 5, and we're going up with the slope of 1. What's the other one look like?
Starts at 3.
Okay, it starts at 3, And it
Kind of
looks
a
like a
little-
square root graph.
Yeah,
Yeah.
yep.
Looks like
And
square.
so
Kinda
it
like
looks
a
something
half
like this.
Yeah.
Do you think it's gonna cross the line?
Yeah, probably,
Even if I can't pick out exactly,
yeah.
what might be a good candidate for where I might cross the line?
Seven.
Okay, what is 7 minus 3?
4.
4? Okay, oh, that's looking pretty good there, huh? And 7 minus 5?
3.
Yeah,
And this one is the square root of 4?
yeah, that looks good.
Okay, so it looks like they should cross at 7 too. Looks like I drew my
I love it.
curve a little too
You're pretty close.
large, but
Not
I'm
judgy.
just bringing it down a little bit there. All right, can you accept that really just one solution seems reasonable?
Yeah,
Yes.
Should I even hunt for another one?
no,
This line's never gonna curve back up.
no.
I mean, so it's looking good. Now let's just look at what happens algebraically. What would be a reasonable thing to do to try and solve this algebraically?
Square both sides.
Square both sides. And what is the left side squared?
X minus 3.
X minus 3 and the right side squared?
X squared minus 10x plus 25.
Plus 25. Can I combine those?
Yep,
What are they becoming?
x squared minus 11x plus 28.
Boy, I hope those nice factors of 28 come in handy. What numbers would be useful ones?
-4, -7.
-4 and -7. But this now appears to have two solutions. All right. What did we do that introduced an extraneous one? Think about what
Squared both sides.
squaring both sides is in effect like multiplying both sides by variables. Are there variables on both sides? Yes. So squaring both sides is multiplying both sides by variables. And so that could introduce an extraneous solution. Take a moment and draw what you can on here to explain our extraneous solution is not without any meaning. Can you find why 4 is the extraneous solution? Because there is a good visual understanding of why 4 is the extraneous solution.
Well, because
Makes
when
it
you,
not a function of that. Or
when you did it, when you squared it, then you took it. Because there's something out of the.
no, so it makes this right here.
4 minus 2.
Oh,
Now, all of a
okay,
sudden,
I
it's
was
not a
doing the
function of
wrong
y.
thing. That's what I
Yeah.
was trying to say, so
So
something like
now,
the square is.
yeah, so now it's not a function of y.
I went the wrong way.
It's a function of x, but we're not having a function of x, it's a function of y.
Yeah.
Because we have a limited domain, it doesn't work.
Okay, does this parabola have a phantom part?
Range too, but domain, like we.
Yeah.
Right, like, it's like only
Yeah, I see what you mean. Yeah. And we can't.
Can you go ahead and sketch the phantom half of the parabola? Like the part that, the underworld half of that parabola. What does it look? Can you sketch it on your paper? What would it look like?
Sideways parabola.
And so what point would it go through?
We go to the point.
So
Or -1,
or
-1,
-1, right? Because a parabola should go over 1, up 1 as its first.
yeah.
And then it should go over how many?
2 up 4.
4 and 2. So here's the phantom half, and then 4, 5, 6, 7, 8, 9, and 3. Here's the phantom half of the parabola. Okay, that's not part of the graph of x minus 3, it's part of the graph of negative square root of x minus 3. And look, it crosses at 4. So it's not shocking that we found not just any old random number, but we found where it, when we squared both sides, we ended up with a full-on horizontal parabola rather than just a half a horizontal parabola. And so the phantom half crosses there. This is interesting in the sense that you might end up with, you can even end up with 2 extraneous solutions. You can, if your phantom half gets hit by the line twice, can you imagine a line going something like this? Where it only hits the phantom half, but doesn't hit the real half at all? You can end up with an equation when you square both sides, you get 2 solutions and neither one of them works.
Yeah.
Which is very funky. Or you could end up squaring both sides if the line instead touches the real part of the parabola twice. You could get 2 solutions and they both are real. They're both actual ones. In a sense, you have no choice but to do the squaring. You just have to be aware that you might have introduced a phantom one, but maybe not. Maybe they're both very real and they could both continue to work. And so that's kind of a significant part of how we end a high school, at least as far as the 3 major courses, with some complexity of solving strategies that work our way through into, and that cause some trouble. So the last things, just looking back at our big list, to express this possibility that equations involving rational and radical expressions, solutions continue to include the possibility of 1 or more rational numbers, as well as complex numbers and no solutions. But this process over on the far side of multiplying by variable expressions introduces these possibilities of extraneous solutions and missing solutions. And then finally, we're not doing anything because we're running out of time, and that's what I had planned for. Exponential expression, that shouldn't be expressions, that should be equations. We now got one more new opposite or inverse operation, the idea of logs. And that's kind of a tour of 6th grade through high school of, can you feel it, how it's not just new methods all the time, but there's sometimes a big development in the meaning of equation, what kind of equations we're allowed to deal with, and what does a solution mean? So sometimes when you find yourself kind of annoyed that students aren't using the word solution properly, maybe we can recognize we haven't helped them to let their understanding of this big concept of solution develop to the place where we are at, and they may be still sitting with the idea of a solution that was what they developed in 6th and 7th grade. And we have to consciously say, we use that old word in one way, but now we've got it in a much more complicated way along the way. So anyhow, I hope our tour of equations and solutions and methods from 6th grade up through high school was somewhat interesting. Anybody any last comments or questions?
Thank you.
Thank you.
Okay, so you will be invited to a folder that has that document that we've been looking at about the development of equation, solution, and systems, but also electronic versions of all the activities that are there in that packet. So if any of them are appropriate for what you're teaching or how you want to work with someone, they're all there. And I believe Danielle said she's going to take a picture of the sign in here that has your emails and invite you to that folder so that you have it all by tomorrow at the latest.
Cool.
Thank you, Jeff.
Thank you so much.
All right. Well, thank you. Hope life is good for you up there in Oregon. We're heading into a nicer time of year here. It's been hot a little bit. I was out at Palm Springs and it was 112 yesterday, and that was hot. So I guess you don't experience 112 up there too often, huh?
No, not really.
Okay, it's nothing to be excited about. So it's not a good part of being down here. So enjoy the rest of your day and look forward to hopefully seeing you some other time. Right. All right. Take care.
All this going back in there. The whiteboard stuff is, but the package, the paper and the algebra tiles go back to with Danielle to California. Not sure what happened with that.
Yeah, he said that he wasn't in charge of the title.
Yeah.
Was not the title that I thought was gonna be here.
No. Interesting stuff though.
Yeah.
Please, I'll use some of these, I think.
Yeah.
The one I did last year was more interesting.
But that was more hands-on, I
Yeah,
thought, for sure. Yeah.
More project based. Yeah.
Yeah, I'm not sure what happened with that.
Well, we got the, alpha tile.
Yeah.
Whiteboard.
Enjoyed that algebra
I think we can.
I like algebra title.
I do too, but I reaffirm that I will never use foam ones in a classroom.
Yeah,
One
I
thing
would
little
just
kids can chew on them.
We'll stab them.
Yeah,
I
I
have
have,
writing on stuff.
yeah, I already have a hard enough time with the foam erasers.
You know, I won't use these either, you know, it works really well, go to Joann's and get sheets of felt, cut them up. And then when they get dirty, you throw them in the washing machine.
It's a good idea, because I'm sick and tired of the kids drawing inappropriate things on them.
Yeah, and they can't, you get black and then they can't draw on them. What?
John Kaminsky.
But he is, at least doing something, because I am not kidding you, he was a head down,
Yeah,
no work.
he's a very smart kid.
Oh, yeah,
Thinker.
he's a pill. Just a thinker. Well, I feel like we should cautiously but persistently address this
I
thing.
just am wondering how much ruffling I need to do this year versus just kind of,
Well,
because I already feel like
nothing's gonna change this year, but like, we could start putting a bug in the ear, like.
Yeah, because I've already
Hey,
been saying
I've
like,
been
hey,
thinking, this is concerning to me.
well, we're already allowing kids,
But
we're already allowing kids to only take algebra 1A, algebra 1B, and then sometimes take algebra 1.
that's not okay.
Not even taking geometry.
Yeah, I don't think that's okay. I really feel like in Vail, that's one thing that I don't understand at a high school level.
there's this thing of like, well, kids just can't do it. So we're gonna make an easier class. No, kids are not doing it. That is not the same thing as they cannot do it.
Okay, so I have more kids on 504s in Vale than I had on 504s in Ontario. Like, 504s for every little thing.
Yeah.
You know what I mean?